Um, Hello everyone. My name is Vishal Karki. Today, this video, is about how radio waves actually travel and why understanding their behavior is critical for the next generation of wireless technology. We focus on two key areas, the magic of diffraction and why channel modeling is, non-negotiable starting point for designing 5G and beyond. So basically, the core concept Huygens principle and diffraction. One of the most transformative concept in propagation is Huygens principle. It states that every single point on a wavefront acts like a tiny independent source of many waves. And when these waves hit an edge or a gap, the line of source is broken, causing the remaining principle to fan out. This phenomenon, known as diffraction, is what allows the radios to bend around building edges and leak into shadow zones where there is no direct line of sight. So diffraction in the real world urban canyons. So basically, diffraction acts as a safety net for urban coverage. It's explained how a signal can reach a deep user in urban canyon or behind a large pillar. However, there is a diffraction penalty. The deeper an object cuts into the first Fresnel zone, now, the more signal strength we lose. So, yeah. Furthermore, as we move higher frequency, like wave, these waves bend less effectively, making diffraction even more critical to account for the link budgets. Yeah. So basically, now we talk about why realistic channeling, realistic channel modeling, matters more. So we move for propagation mechanism to modeling. The performance of any radio system is ultimately determined by the radio channels. Realistic modeling isn't just an academic exercise, it's the essential basis for system algorithm and antenna design. So without reliable models that reflect the real world physics like reflection, transmission through layered walls, and scattering, it is nearly impossible to design systems that will actually function. So, and function in complex environments. So, and the challenge of 5G and wideband channels. As we push into the 5G and beyond, we deal with wideband channels that occupy massive chunks of spectrum. In this environment, channel acts like a natural graphic equalizer, boosting some frequency while creating deep notches in other due to multiple echoes. So realistic modeling always, it allows engineers to predict the frequency, selective fading, and design advanced technology like MIMO and OFDM to explore the structure of the channel rather than just suffering from its losses. So basically, yeah. And to conclude, to conclude, um, um, you know, the design for reality. In summary, we can say that, understanding mechanism like diffraction changes our perspective from simple path loss to a complex bending environment. By using statistical and deterministic models that account for real-world behaviors, we ensure that our 5G networks are resilient, high capacity, and capable of delivering reliable service in the most challenging urban landscapes. Yeah, thank you. Thank you for everything. And that is it for today's video. Thank you so much.